June 24, 1941. A dusty crossroads near Raseiniai, Lithuania. The lone Soviet KV heavy tank sat motionless on soft ground, its 76mm gun pointed toward the German rear. Behind it lay 12 destroyed supply trucks, their twisted metal still smoking in the summer heat. Ahead, stretching back toward German lines, sat the scattered wreckage of 4 50mm anti-tank guns, their crews dead beside them. Oberst Erhard Raus, commanding Kampfgruppe Raus of the Sixth Panzer Division, stared through his binoculars at this single obstacle that had severed his supply line for nearly 18 hours. His forces had established bridgeheads across the Dubysa River. Wounded men needed evacuation. Ammunition required replenishment. But this one Soviet tank, positioned perfectly at the vital crossroads, had stopped everything. The mathematics were simple and terrifying. 4 anti-tank guns had fired repeatedly at close range. Every shell had either bounced off or failed to penetrate. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. An 88mm anti-aircraft gun, positioned 730 meters behind the Soviet tank, had been destroyed by return fire before it could complete targeting. German sappers had attempted nighttime attacks with satchel charges, achieving nothing except revealing how little conventional weapons could accomplish against this armored monster. What Raus witnessed that morning represented more than tactical frustration with a single stubborn enemy. It was physical proof that Soviet tank designers had solved a fundamental problem in armored warfare that German engineers had not fully grasped. The relationship between armor thickness, slope angle, and effective protection had been understood theoretically for years. Soviet designers had actually built it into production tanks, creating vehicles whose armor defeated German weapons through geometry as much as through raw thickness. The story of how sloped armor transformed the Eastern Front begins not with the KV that stopped Kampfgruppe Raus, but with the 34 medium tank that would become the most produced tank of World War II. Soviet engineers had designed a vehicle whose 60-degree sloped armor made it nearly invulnerable to standard German anti-tank weapons in the summer of 1941. German tank crews would spend the next 4 years trying to overcome advantages built into the 34's basic design. The 34's development traced back to Soviet experiences in the Spanish Civil War and observations of armored warfare development in the late 1930s. Designer Mikhail Ilyich Koshkin led the team at the Kharkov locomotive factory that created the A-32 prototype in 1939. The design incorporated several revolutionary features for its time. Sloped armor at 60 degrees from vertical on the glacis plate, a powerful 76.2mm gun capable of defeating any tank then in service. A 500-horsepower V2 diesel engine that provided excellent mobility while being less prone to catching fire than gasoline engines. Wide tracks that distributed weight effectively across soft ground. Soviet tank doctrine emphasized mass production of reliable vehicles that could be manufactured by relatively unskilled workers under wartime conditions. The 34 embodied this philosophy perfectly. Welded construction simplified manufacturing compared to riveted designs. The sloped armor required less steel to achieve equivalent protection compared to vertical armor. The diesel engine used fuel that was less refined and therefore easier to produce than high-octane gasoline. Every design choice reflected the reality that this tank would be built by the tens of thousands under conditions that precluded precision manufacturing. The Armored Directorate requested heavier armor and a more powerful gun than the initial A-32 prototype provided. Koshkin's team responded by increasing armor thickness while maintaining the crucial slope angles that made that armor effective. The resulting 34 entered production in January 1940. Full-scale production began in June 1940, giving Soviet factories a full year to refine manufacturing processes before war began. By June 22, 1941, when Germany launched Operation Barbarossa, Soviet forces possessed approximately 1,034 tanks. This represented only about 5% of total Soviet tank strength, but it was concentrated in specific mechanized corps positioned along the invasion routes. The 4th, 6th, 8th, and 15th Mechanized Corps, together possessed roughly 70% of all 34s then in service. These formations would provide German forces with their first encounters with Soviet armor that their weapons could not reliably penetrate. The 34's armor scheme represented a fundamental breakthrough in tank design. The frontal glacis plate, sloped at 60 degrees from vertical, provided effective thickness far exceeding its actual 45 mm thickness. When a shell struck sloped armor, it had to penetrate through more steel than if that same thickness were mounted vertically. A 45 mm plate at 60 degrees presented effective thickness of 90 mm when struck by a projectile traveling perpendicular to the ground. More importantly, sloped armor increased the likelihood that shells would ricochet rather than penetrate. A projectile striking armor at an oblique angle encountered forces that deflected it away from the plate rather than through it. German armor-piercing shells, designed to penetrate vertical armor efficiently, often bounced off the 34's glacis without causing damage. The turret armor, sloped at 30 degrees and 60 mm thick at the face, provided similar benefits. German forces first encountered 34s and KV tanks on June 23, 1941, the second day of Operation Barbarossa. The reports that filtered back through Wehrmacht channels described weapons that standard German anti-tank guns could not defeat. Accounts documented shells bouncing off Soviet armor at ranges where German guns should have achieved penetration. Anti-tank gun crews reported firing repeatedly at 34s without observable effect. One widely reported incident captured in German after-action reports described a 34 that received 23 hits from a determined 37 mm anti-tank gun crew. The German gunners fired every round they possessed. Not a single shell penetrated. The only damage achieved was jamming the tank's turret ring, preventing turret rotation but leaving the vehicle otherwise operational. The 34 eventually withdrew under its own power. The 37 mm PaK-36 anti-tank gun, standard German infantry anti-tank weapon in 1941, could penetrate 29 mm of 30-degree sloped armor at 500 meters using standard armor-piercing ammunition. Against the 34's 60-degree glacis plate, penetration was effectively impossible at any range. German soldiers began calling the PaK-36 the Panzeranklopfgerät, the tank door knocker, because firing it at 34s merely announced the gun crew's position without inflicting damage. Another documented incident involved a 34 that received over 30 direct hits from a battalion-sized contingent of 37 mm and 50 mm anti-tank guns. The tank survived intact and drove back to Soviet lines several hours later. The crew likely suffered hearing damage from the concussive impacts and endured intense heat inside the vehicle, but the armor had protected them completely from weapons that would have destroyed any German tank of that period. German tank crews faced similar frustrations. The Panzer III, Germany's primary medium tank in June 1941, mounted either the 37 mm KWK-36 gun or the 50 mm KWK-38 gun. Neither weapon could reliably penetrate 34 armor at normal combat ranges when firing at the frontal arc. Lieutenant Stupe's Panzer III scored 5 hits on a 34 during one engagement, once at approximately 20 meters and 4 times at 50 meters, using Panzergranate 40 armor-piercing rounds from the 50 mm gun. None achieved penetration. No noticeable effect occurred. The Panzer IV, armed with the short-barreled 75 mm KWK-37 howitzer-type gun, possessed superior high-explosive capability but inadequate armor-piercing performance against 34 armor. The short 75 mm gun had been designed primarily for infantry support rather than tank versus tank combat. Its low muzzle velocity meant armor-piercing shells lacked the kinetic energy needed to penetrate sloped armor reliably. German forces found themselves compelled to employ weapons never intended for direct anti-tank work. 105 mm field howitzers were pressed into direct-fire roles against Soviet armor. The famous 88 mm anti-aircraft gun, designed to shoot down bombers at high altitude, became the Wehrmacht's most effective anti-tank weapon by default, because nothing else worked consistently. The psychological impact on German troops extended far beyond tactical inconvenience. German forces had conquered Poland, France, and the Low Countries with mechanized warfare doctrine that assumed German armor possessed qualitative superiority over enemy tanks. Suddenly, German tank crews faced enemy vehicles their weapons could not defeat frontally. Anti-tank gun crews discovered their carefully aimed shots bouncing harmlessly off Soviet armor. Infantry units found themselves vulnerable to armored vehicles. Their organic weapons could not stop. Field Marshal Ewald von Kleist, commanding panzer forces with Army Group South, called the 34 the finest tank in the world after encountering it in combat. General Heinz Guderian, architect of German panzer tactics, demanded immediate response to Soviet tank capabilities after examining captured 34s. Multiple senior German officers reported phenomena they described as tank terror among their troops, a psychological paralysis that occurred when encountering enemy armor their weapons could not effectively engage. The Battle of Raseiniai, fought from June 23 through June 27, 1941, provided German forces with extensive experience fighting against Soviet heavy armor. The German 4th Panzer Group encountered the Soviet 3rd and 12th Mechanized Corps near the Lithuanian city. The Soviet formations possessed substantial numbers of 34s and KV tanks concentrated for counterattacks against German spearheads that had crossed the Neman River. The fighting demonstrated both the strengths and limitations of Soviet armor in the war's opening weeks. German forces encountered KV tanks whose armor proved impervious to standard anti-tank weapons. The KV-1 possessed up to 75 mm of armor on the turret and hull front, sufficient to defeat all German tank-mounted guns, then in service except at point-blank range. The KV-2, mounting a massive 152 mm howitzer in an enormous turret, could destroy any German vehicle with a single hit while remaining effectively immune to return fire. Yet despite possessing technically superior tanks, Soviet mechanized forces suffered devastating losses during the Battle of Raseiniai and throughout the summer of 1941. German tactical proficiency, superior crew training, effective combined arms coordination, and overwhelming Luftwaffe air superiority compensated for German armor's technical inferiority. Soviet tank crews often possessed minimal training, sometimes only hours of actual driving experience before entering combat. Communication equipment remained scarce, with only company commanders' tanks equipped with radios. Other tanks communicated using signal flags, severely limiting tactical coordination. Logistical support collapsed under the German onslaught. Many 34s entered combat without armor-piercing ammunition, carrying only high-explosive shells suitable for supporting infantry but inadequate for tank combat. Fuel supplies proved inadequate, leaving tanks abandoned when they ran dry despite being mechanically functional. Recovery vehicles and maintenance support, already insufficient before the war, became effectively non-existent as Soviet forces retreated in disorder. The 4th Mechanized Corps possessed 414 34s and KV tanks on June 22, 1941. By July 12, 45 remained operational. The 6th Mechanized Corps entered the war with 450 new tanks. By June 27, the formation had ceased to exist as a combat-effective force. The 8th Mechanized Corps possessed 899 tanks of all types on June 22. By July 7, 43 tanks remained. These catastrophic losses occurred despite 34 and KV armor proving largely invulnerable to standard German weapons. Operational factors, not technical inferiority, destroyed Soviet mechanized forces in summer 1941. Tanks abandoned due to mechanical failure, fuel exhaustion, or lack of ammunition far exceeded tanks destroyed by German fire. Luftwaffe strikes against Soviet tank columns inflicted severe losses before Soviet armor could reach battle positions. German tactical skill in outflanking, isolating, and bypassing Soviet strongpoints prevented Soviet armor from exploiting its technical advantages. But German commanders recognized they faced a fundamental problem that tactical skill alone could not solve indefinitely. Soviet industry possessed the capacity to produce 34s and KV tanks in quantities that would eventually overwhelm German forces if the armor disparity remained unaddressed. Every 34 that reached the battlefield represented a threat that German tanks could not reliably engage from the front. Every encounter reminded German crews that Soviet designers had created something qualitatively superior to German medium tanks. The lone KV tank at Raseiniai crystallized these concerns into a single dramatic example that senior German officers could not ignore. Throughout June 24th and into the morning of June 25th, this one Soviet tank held its position at the critical crossroads, engaging any German vehicle that attempted to pass. 50mm anti-tank guns achieved multiple hits without effect. The tank's armor deflected shells that should have penetrated according to German ballistic calculations. German forces attempted increasingly desperate measures. An 88mm anti-aircraft gun crew positioned their weapon approximately 730 meters behind the Soviet tank, hoping to achieve rear armor penetration. The KV crew spotted the anti-aircraft gun while it was being positioned, turned their turret, and destroyed it with their first shot. The Germans had discovered that the KV's frontal armor was impenetrable, its side and rear armor were difficult to engage, and its crew possessed exceptional discipline under fire. Engineers attempted nighttime infiltration with satchel charges, explosive devices that might damage tracks or jam the turret even if they couldn't penetrate the armor. The KV's machine guns drove them off. German infantry learned that approaching this tank on foot was suicidal regardless of what explosives they carried. Inside the KV, conditions must have been nightmarish. Summer temperatures in Lithuania can exceed 30 degrees Celsius. Inside a sealed steel box under the sun, temperatures would have climbed far higher. The concussive impacts of dozens of shells striking the hull and turret would have been deafening. Modern understanding of traumatic brain injury suggests the crew likely suffered repeated concussions from the shock transmitted through the tank's structure. Their eardrums would have ruptured, blood would have flowed from ears and noses. Some crew members may have lost consciousness temporarily, yet they continued fighting. Every time German forces attempted to bypass or eliminate the roadblock, the KV engaged them. The crew had to be suffering from heat exhaustion, dehydration, hearing damage, and likely concussion symptoms. Still, they fought, maintaining their position for 22 hours against an entire German division. Early on the morning of June 25th, German forces coordinated a final assault. Panzer 35 light tanks from the 65th Tank Battalion maneuvered to distract the KV crew, while another 88mm anti-aircraft gun crew positioned their weapon behind the Soviet tank. The tactic succeeded. While the KV crew focused on the light tanks presenting frontal threats, the 88mm gun achieved firing position and engaged from the rear. Several armor-piercing shells struck the KV's thinner rear armor. 2 achieved penetration, entering the fighting compartment. German infantry rushed forward, expecting to find the crew dead. Instead, the turret began moving again. The stunned crew members, recovering from the shells that had penetrated, were attempting to continue fighting. German pioneers pushed grenades through the 2 holes the 88mm shells had created. The resulting explosions finally killed the crew. German soldiers who approached the destroyed tank found 6 dead crew members inside. The sight of these men who had fought so courageously impressed even their enemies. German forces buried the KV crew near the battlefield with full military honors, a mark of respect for extraordinary valor. In 1965, Soviet authorities exhumed the remains and reburied them at the military cemetery in Raseiniai, where they rest today. The Raseiniai KV's stand represented extreme circumstances, but it demonstrated principles that applied to thousands of 34 engagements throughout the war. Soviet sloped armor, when combined with adequate crew training and tactical support, created tanks that German forces could not reliably defeat with standard equipment. The 34's armor scheme made it invulnerable to most German weapons when engaged frontally at typical combat ranges in 1941. German High Command responded to the armor crisis with immediate urgency. On November 18, 1941, a special Panzer Commission arrived at the Eastern Front to assess Soviet tank capabilities and recommend responses. The commission included Ferdinand Porsche, head of the Tank Commission, Oskar Hacker from Steyr, Colonel Sebastian Fichtner from the Ordnance Directorate, Engineer Heinrich Kniepkamp, and senior representatives from Krupp, Daimler-Benz, Henschel, MAN, and Rheinmetall. This gathering of Germany's leading tank designers and manufacturers reflected the seriousness with which German leadership viewed the threat. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Commission examined captured 34s and KV tanks in detail, measuring armor thickness, testing mobility in winter conditions, evaluating the harsh Eastern Front environment. They studied how Soviet tanks performed on primitive roads and cross-country through mud and snow. They interviewed German commanders and tank crews about combat experiences. The resulting report would fundamentally influence German tank development for the remainder of the war. The Commission identified 3 critical 34 features that German tanks lacked. First, the long overhanging gun that provided excellent firepower while maintaining low vehicle profile. German designers had traditionally mounted guns in turrets that didn't extend far beyond the hull, limiting gun elevation and depression angles. Second, exceptional off-road mobility derived from wide tracks that distributed weight effectively. German tanks used narrower tracks that increased ground pressure, causing them to bog down in mud and snow where 34s could traverse freely. Third, and most critically, sloped glacis armor that provided protection far exceeding its actual thickness. This third feature sparked intense debate among German designers. Sloped armor wasn't a new concept. German engineers understood the ballistic advantages of angling armor plates. But German tank design tradition emphasized other priorities. Vertical armor simplified internal layout, provided more interior volume for the same external dimensions, and eased manufacturing compared to complex sloped structures. The 34 demonstrated that these conveniences weren't worth the vulnerability they created. The Panzer Commission recommended developing a new 30-ton medium tank incorporating 34 features while maintaining German engineering standards. The Weapons Department held that Germany couldn't simply copy the 34, as General Guderian had suggested, because Soviet production methods and material availability differed fundamentally from German capabilities. Soviet designs used aluminum, chromium, molybdenum steel alloys that Germany lacked in sufficient quantities. The V2 diesel engine required manufacturing expertise and fuel infrastructure Germany had not developed for armored vehicles. Daimler-Benz and MAN received contracts to develop competing designs, both designated VK 30.02, for a 30-ton tank incorporating key 34 advantages while remaining compatible with German industrial capabilities. Daimler-Benz produced the VK 30.02D, which closely resembled the 34 in layout with rear-mounted engine and drive, sloped armor throughout, and similar general appearance. MAN created the VK 30.02M, which retained more traditional German layout with front-mounted transmission, but incorporated sloped frontal armor. Hitler preferred the Daimler-Benz design, seeing it as the quickest path to fielding a 34 equivalent. The Weapons Department favored the MAN design, arguing it better suited existing German manufacturing processes and supply chains. After extensive debate, the MAN design won approval. This decision, though technically sound from a manufacturing perspective, delayed fielding the new tank because the MAN design required more development work than adapting existing 34 concepts. The resulting Panther tank, designated Panzer V, incorporated sloped frontal armor at 55 degrees, similar to the 34's 60-degree slope. The glacis plate measured 80 mm thick, providing effective thickness approaching 140 mm. This made the Panther's frontal armor effectively immune to most Allied tank guns at normal combat ranges. The Panther mounted a long 75 mm Kyuk-42 gun with excellent penetrating power and accuracy. Wide tracks improved ground pressure distribution, addressing mobility problems German tanks had experienced in mud and snow. but the Panther arrived too late to prevent 2 years of fighting at severe disadvantage against 34 armor. The first Panthers entered combat at the Battle of Kursk in July 1943, exactly 2 years after German forces first encountered 34s. Those 2 years witnessed thousands of engagements where German tank crews faced enemy armor. Their weapons couldn't reliably penetrate, while Soviet guns could destroy German tanks at combat ranges. German industry responded to immediate armor threats by upgunning existing tank designs. The Panzer IV, originally armed with a short 75mm howitzer-type gun, received the long 75mm Quake-40 gun beginning in spring 1942. This weapon could penetrate 34 armor at ranges beyond 1,000 meters when striking at favorable angles, finally giving German tank crews a weapon that could engage Soviet medium tanks effectively. The Panzer III received the 50mm K-39 long-barreled gun in an attempt to improve its anti-tank capability. Even with this improved weapon, Panzer IIIs struggled against 34 armor. A German report from May 1942 noted that combating the 34 with the 5cm KBUK tank gun is possible only at short ranges from the flank or rear, where it is important to achieve a hit as perpendicular to the surface as possible. This admission, appearing in official documents 18 months into the Eastern Front campaign, acknowledged that German medium tanks couldn't fight 34s on equal terms. German forces developed numerous stopgap measures to counter Soviet armor advantages. Assault guns based on obsolete tank chassis mounted captured Soviet 76.2mm guns or German weapons in armored fighting compartments. These Panzerjäger, or tank hunters, provided mobile anti-tank capability using weapons that could penetrate 34 armor. The 88mm anti-aircraft gun, proven effective against all Soviet armor, was mounted on tank chassis to create the Ferdinand tank destroyer and later models. The famous Tiger heavy tank, armed with the 88mm KBUK 36 gun and protected by armor up to 100mm thick, could defeat any Soviet tank in 1942 and 1943. But Tigers were expensive, complex, mechanically unreliable, and produced in limited numbers. Only 1,347 Tiger ones were built during days, the entire war. They could not be everywhere German forces faced 34s. Soviet designers did not rest, while German industry struggled to respond. The 34 underwent continuous improvement throughout the war, with 5 additional models following the initial 1940 production version. The model 1941 added a longer 76.2mm L40 gun and rolled plate turret. Later production switched to cast turrets and incorporated wider tracks, improved vision ports, and better engine cooling. Armor thickness increased progressively, with some areas reaching 70mm by the Model D. The most significant upgrade came with the 34-85, which entered production in 1943. This variant featured a larger 3-man turret that addressed the original 34's most serious flaw, the cramped 2-man turret that forced the commander to aim the main gun. The 34-85's turret accommodated a dedicated gunner, allowing the commander to focus on tactics and battlefield awareness. The 85mm gun provided firepower adequate to engage German heavy armor at reasonable ranges. The enlarged turret solved ergonomic problems that had plagued 34 crews since 1940. The original design's 4-man crew was squeezed into a compact hull and turret that severely limited efficiency. Most contemporary medium tanks, including the German Panzer IV and American Sherman, used 5-man crews with the extra crewman dedicated to loading the main gun. The 34's commander served as both tactical leader and gunner, overloading one person with incompatible responsibilities. In combat, commanders needed to assess threats, communicate with other tanks, and make tactical decisions. Simultaneously, aiming and firing the main gun made all those tasks exponentially more difficult. The cramped interior combined with poor visibility to create conditions where German tankers, despite inferior armor protection, often spotted and engaged 34s before Soviet crews could respond effectively. German crews consistently reported getting off 3 rounds for every one fired by 34s, a result of better crew organization and superior optics as much as training differences. The 34-85 addressed visibility and crew efficiency problems, though the hull remained as cramped as earlier versions. Manufacturing quality presented ongoing challenges for Soviet 34 production. Wartime conditions, especially after German advances forced tank factories to relocate eastward to the Urals, resulted in vehicles that often suffered mechanical defects. Transmissions and gearboxes failed frequently in field service, forcing crews to abandon otherwise functional tanks. Control linkages jammed, requiring crews to keep mallets handy to hammer stuck controls free. Braking required excessive effort because transmission and gearbox were separated by considerable distance within the hull. Yet, despite these defects, 34 production continued at rates German industry never approached. Over 35,000 34-76s were built before production shifted to the 34-85 model. Total 34 production during the war exceeded 64,000 tanks, more than all German tank production of all types combined. Stories circulated of unpainted 34s being driven directly from factory floors into combat, reflecting the desperate circumstances of Soviet industrial mobilization, but also the effectiveness of a design that could be manufactured at such extraordinary scale. The numerical advantage Soviet armor achieved by 1943 through 45 proved decisive regardless of individual tank quality. German panzer divisions, even when equipped with technically superior Panthers and Tigers, faced Soviet tank armies that outnumbered them by factors of 3 to 1 or greater. Soviet operational doctrine evolved to exploit numerical superiority through deep operations that surrounded and isolated German forces, preventing the Germans from concentrating their limited armor where it was most needed. German forces captured and operated numerous 34s throughout the war, providing direct comparison between Soviet and German tanks from the German crew perspective. Wehrmacht mechanized units, desperate for reliable armor as their own vehicles degraded, eagerly used any captured 34s they could obtain. An estimated 434s of various models entered German service, designated Panzerkampfwagen 34747R. German crews operating captured 34s consistently noted several characteristics. The armor provided excellent protection against German weapons that would destroy German tanks. The wide tracks gave superior mobility in mud and snow compared to German tanks. The diesel engine, though less powerful than German gasoline engines of similar displacement, proved more reliable and less prone to catching fire when hit. The crude construction and poor ergonomics were apparent, but German crews valued functional reliability over refinement when vehicles had to work under combat conditions. Germans added prominent German crosses and swastikas to captured 34s to prevent friendly fire from German aircraft and other ground forces. Recognition was critical because German troops had learned to shoot first at 34 silhouettes. Sometimes additional armor plates were welded to hull sides and turrets, attempting to improve protection beyond the already formidable base armor. In rare cases, Germans replaced the 85mm gun with captured German 88mm guns, creating hybrid vehicles that combined Soviet armor protection with German firepower. The combat statistics for 34 performance throughout the war reveal a more complex picture than simple technical superiority suggests. While the 34 possessed armor advantages over German tanks in 1941, Soviet tank forces consistently suffered higher loss rates than German armored units through most of the war. In 1941, Soviets lost an average of over 7 tanks for every German tank lost. The ratio improved to approximately 6 to 1 in 1942, 4 to 1 in 1943 and 1944, and roughly 1.2 to 1 in 1945. These loss ratios reflect factors beyond armor protection. German crew training remained superior through most of the war. German tactical doctrine emphasized combined arms coordination that Soviet forces struggled to match until late in the conflict. German optics and fire control equipment provided advantages in target acquisition and engagement accuracy that partially offset armor disadvantages. Luftwaffe air superiority in 1941 and 42 inflicted devastating losses on Soviet armor before tanks could reach battle positions. But the ratios also demonstrate that armor protection alone doesn't determine tank effectiveness. The 34's sloped armor made it difficult to destroy frontally, but tanks can be engaged from flanks and rear where armor is thinner. Skilled German tank crews learned to maneuver for favorable shot angles rather than engaging 34s frontally, where their weapons were ineffective. German anti-tank guns, positioned in prepared defensive positions, could engage 34s at close range, where even the 37mm PaK-36 could penetrate turret rings, mantlets, or other weak points. An examination of damaged 34s in repair workshops during August and September 1942 found that 54.3% of losses were caused by the German long-barreled 50mm Ku-39 gun. This weapon, inadequate against 34 frontal armor, remained effective against side and rear armor at typical combat ranges. German crews learned to avoid frontal engagements and seek flanking positions where their weapons worked. The Battle of Kursk in July 1943 marked the high point of German armoured warfare on the Eastern Front and demonstrated both German tactical skill and the ultimate futility of attempting to overcome Soviet numerical superiority. German forces concentrated massive armoured strength for this offensive, including the first combat deployment of Panther tanks and substantial numbers of Tigers. The objective was to pinch off the Kursk salient, destroying Soviet forces within and potentially creating conditions for renewed strategic offensive. The battle featured the largest tank engagement in history at Prokhorovka on July 12, 1943. Though numbers remain disputed, approximately 800 tanks from both sides fought in a compact area, creating chaotic close-range combat where neither side's technological advantages could be fully exploited. Soviet forces suffered significantly higher tank losses than Germans, but Soviet production capacity allowed those losses to be replaced quickly. German losses, though fewer, included irreplaceable Panthers and Tigers that German industry could not replace at rates matching Soviet production. Kursk demonstrated that German tactical and technical advantages, while real, could not overcome Soviet numerical superiority and willingness to accept heavy losses to achieve operational objectives. After Kursk, German forces never regained strategic initiative on the Eastern Front. Soviet tank armies, equipped primarily with 34s, drove steadily westward through 1944 and into Germany itself in 1945. The 34's sloped armor, which had seemed invincible to German tank crews in June 1941, gradually lost its protective advantage as German weapons improved. The long 75mm guns on upgunned Panzer IVs could defeat 34 armor at reasonable combat ranges by 1942. The Panther's 75mm KWK-42 gun could penetrate 34 armor at ranges exceeding 1,500 meters. Tiger 88mm guns made 34 armor nearly irrelevant, punching through frontal armor at any practical combat range. But by the time German guns could reliably defeat 34 armor, Soviet production had created such overwhelming numerical superiority that individual tank capabilities mattered less than force ratios. German panzer divisions in 1944 typically fielded 50 to 80 tanks when at full strength, and combat attrition often reduced that to 30 or 40 operational vehicles. Soviet Tank Corps fielded 200 or more 34s, supported by assault guns and self-propelled artillery. The legacy of 34 sloped armor extended far beyond World War II itself, fundamentally reshaping tank design philosophy worldwide. Every major tank developed after 1945 incorporated sloped armor as a standard design feature. American designers, studying captured German and Soviet tanks after the war, recognized that sloped armor provided protection advantages that couldn't be ignored. The M46 Patton tank, entering service in 1949, featured sloped frontal armor influenced directly by 34 and Panther design principles. British tank development, which had traditionally favored thick vertical armor, shifted towards sloped designs in post-war years. The Centurion tank, considered by many the finest tank design to emerge from World War II, incorporated moderate armor slopes that provided excellent protection for its weight class. Soviet designers continued refining the principles established by the 34, creating the T-34 and T-55 series that dominated global tank exports for decades. The German perspective on 34 armor, gathered from post-war interrogations and examination of captured documents, revealed professional respect mixed with frustration. German ordnance officers acknowledged that Soviet designers had solved fundamental armor protection problems more effectively than German engineers. The simplicity of Soviet sloped armor design, which German engineers had initially dismissed as crude, proved more effective in practice than complex German armor schemes that looked impressive on paper but created manufacturing difficulties. German tank crews interviewed after the war frequently cited 34 armor as the single most significant Soviet tank advantage in the war's early years. The psychological impact of firing at enemy tanks and watching shells bounce off created hesitation and defensive mindsets that Soviet numerical superiority exploited ruthlessly. Crews that had confidently engaged Polish and French tanks in 1939 and 1940 learned caution when facing Soviet armor that their weapons couldn't reliably penetrate. Heinz Guderian, who had demanded immediate response to Soviet tank capabilities after examining captured 34s in November 1941, wrote extensively in his post-war memoirs about the shock of encountering technically superior enemy equipment. German forces had entered Operation Barbarossa confident in their qualitative superiority over Soviet equipment. The 34 shattered that confidence within days, forcing German tactical and technical responses that consumed resources and attention throughout the remainder of the Eastern Front campaign. The mathematical reality of sloped armor's effectiveness can be calculated precisely using trigonometry and metallurgical principles. A 45mm armor plate at 60 degrees from vertical presence, effective thickness of 90mm to a projectile, traveling perpendicular to the ground. This doubling of effective thickness occurs because the projectile must travel through twice as much steel to penetrate the plate compared to vertical armor of the same thickness. The angle also increases the likelihood that projectiles will ricochet rather than penetrate, as the forces acting on a shell striking at oblique angles tend to deflect it away from the surface. German armor-piercing projectiles in 1941 were optimized for penetrating vertical or moderately sloped armor. The projectile tips were designed to bite into armor surfaces perpendicular to their flight path. When these same projectiles struck armor at 60-degree slopes, they often shattered on impact or ricocheted without achieving penetration. German ordnance departments had to develop new projectile designs with improved penetration characteristics against sloped armor, a process that required months of research and testing, while 34s continued destroying German tanks with impunity. The Soviet decision to prioritize armor protection through geometric design rather than raw thickness reflected industrial realities that German planners failed to grasp initially. Sloped armor required less steel to achieve equivalent protection compared to vertical armor. In a nation fighting for survival with limited industrial capacity and raw materials, this efficiency mattered enormously. Soviet factories could produce more tanks with the same steel allocation by using sloped armor designs. The weight savings from thinner sloped armor also improved mobility and reduced mechanical strain on powertrains. German designers, working within an industrial system that emphasized precision manufacturing and complex engineering solutions, initially dismissed Soviet design simplicity as evidence of inferior capability. The 34's crude welding, rough casting, and utilitarian construction seemed primitive compared to German manufacturing standards. But Soviet designers understood something German engineers learned too slowly. Under wartime conditions, simple designs that could be manufactured quickly by semi-skilled workers using available materials were more valuable than sophisticated designs, requiring specialized labor and scarce materials. The 34 could be assembled in approximately 3,000 man-hours by workers with minimal training. A German Panther required approximately 5,500 man-hours and demanded skilled workers for many critical operations. When Soviet factories evacuated eastward ahead of German advances in 1941, they resumed 34 production within months in new locations, using hastily trained workers. German factories, subjected to increasingly heavy Allied bombing from 1943 onward, struggled to maintain production rates even with experienced workers and established facilities. The famous Soviet tank factories at Tankograd in the Urals became legendary for production rates that German industry never approached. Workers labored under brutal conditions, often in unheated facilities during Russian winters, producing 34s around the clock. Quality control suffered compared to peacetime standards, but quantity compensated for individual vehicle defects. Soviet operational doctrine anticipated losing tanks at high rates and planned accordingly, ensuring continuous replacement flows that maintained unit strength despite heavy combat losses. German forces captured extensive documentation about Soviet tank production during their advances in 1941 and 42. These documents revealed production rates that German intelligence initially dismissed as Soviet propaganda. When German industry attempted to match Soviet output, they discovered Soviet claims were accurate. The USSR produced more tanks in single years than Germany produced during the entire war. The 34 alone accounted for production, exceeding all German tank types combined. This production disparity, rooted in fundamental differences between Soviet and German industrial approaches, determined the Eastern Front's outcome as surely as any battle. German forces could win tactical engagements repeatedly, destroying 3 or 4 Soviet tanks for every German tank lost, and still lose the strategic war because Soviet replacement rates exceeded German production capacity. The mathematics were simple and brutal. If Germany produced 100 tanks per month, while the USSR produced 534s per month, German forces would be overwhelmed eventually, regardless of tactical skill or individual vehicle quality. The 34's armor protection, which had triggered German tank development responses, including the Panther and Tiger, ultimately mattered less than Soviet industrial capacity to produce protected tanks at scale. German engineers could design tanks with superior armor, firepower, and mobility. German industry couldn't manufacture them in sufficient quantities to overcome Soviet numerical advantages. By 1943, this reality had become apparent to German military leadership, though ideological commitment prevented them from seeking negotiated peace that might have preserved something from the inevitable defeat. Field Marshal Ewald von Kleist's description of the 34 as the finest tank in the world was accurate in 1941 when German forces first encountered it. By 1943, German Panthers and Tigers possessed superior firepower and armor protection, but the 34 remained the most effective tank of World War II when effectiveness is measured by impact on the war's outcome rather than technical specifications. Its sloped armor made it difficult to destroy, its reliable powertrain kept it operational, its simple design enabled mass production, and its adequate firepower allowed it to engage enemy armor effectively. The comparison between 34 and German tank development illustrates a fundamental principle of military technology that remains relevant today. Technical sophistication matters far less than the ability to produce, maintain, and employ weapons effectively under actual combat conditions. Germany developed more advanced tanks than the USSR throughout the war. Soviet tank forces won the Eastern Front by fielding adequate tanks in overwhelming numbers that German industry and logistics couldn't match. The morning of June 24, 1941, when that lone KV tank blocked Kampfgruppe Raus at Raseiniai, foreshadowed 4 years of German frustration attempting to overcome Soviet armor advantages. The shells that bounced off Soviet armor that morning continued bouncing off throughout the summer and autumn of 1941, while German industry struggled to develop responses. By the time German responses arrived in the form of improved guns and new tank designs, Soviet production had created numerical advantages that technical improvements couldn't overcome. The 34's sloped armor, conceived by Soviet designers seeking efficient protection using limited industrial resources, proved more influential than any other single tank design feature of World War II. It forced German tank development in new directions, influenced Allied tank design throughout and after the war, and demonstrated that geometric cleverness could achieve results that raw material thickness alone could not provide. Every modern tank incorporates sloped armor as standard design practice, a direct legacy of the 34's revolutionary approach to armored protection. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.